Everyone, myself Netravati, studying at Sri Venkateshwara College of Engineering. Today's my topic is nodal analysis, subject network analysis. So let's see what is nodal analysis and a few examples of this. Introduction to nodal analysis. Nodal analysis is a systematic method used in circuits analysis to determine the voltage at each node in an electrical circuit. It is based on Kirchhoff current law, which states that the total current entering a node must equal to the total current leaving the node. This method is simplifies the analysis of complex circuits by reducing the number of equations required to solve unknowns. So let's see what is basic concepts. In nodal analysis, the nodes are defined as points in circuits where two or more components are connected. A reference node, also known as a ground node, is chosen to establish a common voltage level. Voltages at other nodes are measured with respect to this reference node, allowing for the clear representation of the circuit. Steps in nodal analysis. The first step in nodal analysis is to identify all nodes in the circuit and select a reference node. Next, apply KCL at each of the non-reference node to formulate the equation for the circuit. Finally, solve the system of equations to find the node voltages, which can be used to determine other circuit parameters. KCL and node voltages. Kirchhoff current law is fundamental to nodal analysis as it governs the relationship between currents at the nodes. Each equation derived from KCL will involve the node voltages and resistances connected to these nodes. By rearranging these equations, you can express the currents in terms of node voltages, facilitating the solution process. Handling dependent sources. When dependent sources are present in the circuit, their values depend on some other voltage or current in the circuit. It is essential to include these dependent sources in the nodal equation to accurately model the circuit behavior. Special care must be taken to express dependent sources in terms of the node voltages in the equations. Example circuit. Here we can see the example circuit like node A, node B and node C. Consider a simple circuit with two nodes and several resistors connected to a voltage source. Applying nodal analysis, we can derive the equation for the node voltages based on the resistances and the input voltages. This equation illustrates how to practically apply the concepts of the nodal analysis to solve for unknown voltages. Advantages of nodal analysis. Nodal analysis is particularly advantageous for circuits with multiple nodes and components as it reduces complexity. It allows for easy incorporation of various elements such as resistors, capacitors, and inductors in an analysis. Additionally, it provides a clear framework for analyzing the efforts of changing circuit elements of nodal analysis. Limitations of nodal analysis. Nodal analysis can become cumbersome for circuits with a high number of nodes and complex interconnections. It is less effective for circuits where branch currents need to be especially analyzed as it is focused on node voltages. The presence of the nonlinear components can complicate nodal analysis, requiring numerical methods for solutions. Applications of nodal analysis. Nodal analysis is widely used in electrical engineering for analyzing and designing electric circuits. It is applicable in various fields including telecommunication, control systems, and power distribution networks. Engineers utilize nodal analysis to ensure circuits reliability, performance, and effective efficiency in practical applications. So let's see the example of nodal analysis. Here we taken a circuit which has voltage, current, and the resistor, and we know Ohm's law equation. V is equals to I into R. Here we taken I is equals to V by R. I value is 1, 1 plus 2. Here we have two I values. So 1 plus 2 is equals to V1 by R values 10, 20, 10. So V by R, V1 by 10 plus V1 by 20 plus V1 by 10. So 1 plus 2 is 3 is equals to, here we taken V1 common in the three terms. So V1 common means 1 by 10 plus 1 by 20 plus 1 by 10. So 3 is equals to, we get 0.25 V1. So V1 is equals to, here 0.25 is into V1. So if we take V1, 0.25 will go to denominator, so we will get 12 volts. The current through 20 ohm, here we have to find the current through the resistor 20 ohm. I20 is equals to V1 by 20. We already know V1 is equals to 12. 12 divided by 20 is equals to 0.6 ampere.